Okay, so like the title suggests, this is topic 2.6, halogenoalkanes, and these are a group of past paper questions. Okay, I'm just going to whiz through the answers. With this question, I think the mark's a little bit wrong because there isn't even enough lines, but it's likely that you would have got a couple of marks for drawing out the mechanism. So one method of making butanol is reacting sodium hydroxide with 1-chlorobutane. Describe how butanol can be made this way. State any necessary conditions. So it's heat and a reflux. It's got to be aqueous NaOH, because if you don't use aqueous, then you end up with an alkene. State the type of mechanism. It's nucleophilic substitution. You are substituting this nucleophile OH for this Cl. Okay, so a couple of marks come from drawing out this mechanism, and then you've got the marks then. Quality of written communication just means in capital letters. Okay, so 1-chlorobutane is an example of a halogenoalkane. One group CFC, so chlorofluorocarbons, have been shown to play a role in ozone depletion. Most of these ozone depleting substances contain chlorine. Halogen alkanes containing only fluorine do not harm the ozone layer. Okay, so then they introduced a protocol in 1987, meaning that they've been banned and replaced with hydrogen fluorocarbons, which contain fluorine as the only halogen. Why do CFCs deplete the ozone layer and not HFCs? It's because they've got a longer half-life, okay, the fluorine. Also, when you're exposed to UV light from the sun, the chlorine will form free radicals, whereas the fluorine needs a much stronger reaction because it's got quite a strong bond, so that can destroy the ozone layer. The HFC contains no chlorine. The FC bond is harder to break. Okay, so it's to do with the carbon-chlorine bond being a lot easier to break than the fluorine-carbon, and we get the UV light, creates free radicals, and these react with the ozone layer, kind of undergo a free radical substitution. So you would see a free radical substitution happening in the ozone layer, and that can cause lots of problems. Okay, suggest another reason why there is still a concern about ozone depletion. CO2 and other greenhouse gases like methane, which are released when we burn fossil fuels, that might be worth putting in. Remember, I know they're only worth 1 mark, but it's important to get all the relevant information in. Okay, so they can still cause ozone depletion. So moving on to the next bit of this question, it says, what does CFC stand for? CFC stand for chlorofluorocarbons. What can they be used in? They're used in refrigerators, in the lining. They're also used as solvents. What does radical mean? An unpaired valence electron. So free radicals when they've got these electrons that are unpaired. Give a reason why chloromethane breaks down, but the fluoromethane does not. UV light from the sun, the CF bond is too strong. Okay, it requires too much energy to break that bond. In 1960, other halogens such as carbon borofluoride were developed as an effective firefighting material. Okay, when that reacts with sodium hydroxide, bromide ions are formed. How do you test for the presence of these ions? Dilute nitric acid is added first. Why? You need to acidify the reaction. If it's alkali, you won't see a reaction. What's the reagent that we use? This is from GCSE, so it's silver nitrate. You would expect to see a cream precipitate, and here's the ionic equations, the ions involved. So you've got the silver, the bromine, and that's what forms the precipitate. That is the precipitate, the silver bromide. Okay, remember to include your charges because it's an ionic equation. So next question then, same kind of thing, exactly the same question as the first one. Assume the mechanism is the same as the reaction of 1-chlorobutane with OH, exactly the same. So you've got the carbon, it's attracted, because this is more electronegative, to the OH, gives up the electrons, the Cl transfers and swaps with the OH, okay? And I've just drawn that out there. 3 marks, nice 3 marks. Bromoethane can also go an elimination reaction with OH. What does it form? It forms an alkene. And with this one it would be ethene, because that's the number of carbons you've got. This one then is NaOH in ethanol and heat. Okay, so that's why I said if it's aqueous NaOH, it's this reaction. If it's ethanol, it's the elimination reaction. Okay, so be careful because their conditions are quite similar. Then it asks you to draw out 1,1,1 trifluoro, so 3 fluorines on the first carbon, and then 2 bromo, 2 chlorine, ethane. Okay, ethane is 2 carbons. It's used as a general anaesthetic. Another use is used as solvents. It's also used in our refrigerators. Okay, next question then had quite a little bit of information here, all about how much ozone depletion they cause and then their relative bond strengths. Okay, comment on why the C halogen bond energies and the number and type of atoms per molecule are related to their destructive effects. So it's easier to break the bond in the CBr or in the Cl compared to the CF. So they're damaging the ozone layer. Okay, so they become more damaging because it's easier to break. That UV light will break them. Okay, the more there are of them, so in this one you've got 1, 2, 3, 4 compounds. Okay, same here, you've got 4, but you've got that Br, which is much easier to break. So the more Brs you have, the easier that bond to break is, the more ozone depleting negative effect it has. Okay, so this question then was something from 2.5, okay, so it asked you to talk about the reaction between butane and chlorine to form 1-chlorobutane. So I gave out the overall equation, okay, I gave the conditions, UV light, heat, is free radical substitution, and then I kind of wrote, I would be expecting a little bit more detail from you guys, okay, but I just wrote quite quick detail. So it's initiation, free radicals, you need UV light here to split them, so it splits, 1 electron goes that way, 1 electron goes that way. Then it's propagation, creating more free radicals, and then termination, the combining of free radicals. Okay, give the equation for the reaction between 1-chlorobutane and aqueous sodium hydroxide. So it's aqueous, so we're making an alcohol. Okay, so NaOH will swap with the Cl, and then you end up with an alcohol and NaCl, nucleophilic substitution. Then describe a test. So you'd add nitric acid, add silver nitrate, chloro would form white precipitate, bromo would form a cream precipitate. Okay. What is the problem with chlorofluorocarbons leaking? Damage to the ozone layer. Explain in terms of bond strengths why 1,1,1-trichloroethane has the effect on the ozone layer, but methyl cyclohexane does not. Okay. The bonds are harder to break when you're in this cyclic form, okay, because they're more closely compact and into each other, so you get stronger bonds. The other thing is cyclo stands for hexane in a circular fashion, or it doesn't stand for having a chlorine attached, and we know that this chlorine bond is the problem because you're creating free radicals. You can't really create free radicals there. Okay, how would you test for this double bond? Bromine water, again, a GCSE thing. If you add bromine water, the double bond will decolorize it, so it should go from orange to clear, whereas this one doesn't have a double bond, so you won't see that reaction. And then finally, another one of these questions where it talks about life in the atmosphere and its relative ozone depletion potential. So when CFCs are exposed to UV light, they split. The chlorine can then damage the ozone layer. B and C are more harmful because they contain more chlorine atoms, and they also have a longer lifetime than D. So you most probably would be saying that this one's the most destructive because it's got that Br, and we know that that's even a weaker bond than Cl. However, that's only in the atmosphere 120 days, whereas this one is in the atmosphere for 75 years. So I know that one causes a lot more damage, but that one has got 75 years to cause that damage over and over again. Okay, so check your answers. Maybe can you please do it in a different colour so I can see it, and then you can email me if you've got any problems.